Hey there, CPO here, and we are continuing on with the heli build. I want to finish up the servos and work on getting the links to the swash plate and get the main gear, main shaft mounted, motor mounted, servos. So a lot of exciting stuff here because this bare frame assembly is it's finally going to get some love. So it's been sitting here just waiting for something to happen, and it's about time some of these other parts that I've been putting together are going to get to go inside that frame. So what I want to do now is finish up working on the servos. I was going to do this off camera, but then I realized one of the reasons why I wanted to do this video is because there are a lot of things that are taken for granted that beginners may not even be aware of. So I didn't want to just go in and you know, put everything together that sounded like it was simple while leaving out some maybe relevant information that could be helpful to a beginner such as me. So I'm a beginner too, so I'm learning some things as I go. As I learn, as I do this on camera, I'm learning and then sharing as I go. So if I do it off camera, then there's a lot of things I may be learning that I'm not remembering to share later on. So that's why I'm still going to be finishing up here with the servos, but not for much. So I do want to show you this new cool tool I got. It is a servo arm alignment tool. Not really. It's basically just a multi-purpose square. I saw this at Harbor Freight for like $4 or $5. And I'm a big fan of these kind of things anyway. Around the house, I'm always looking for a little square or a way to square up things, or a little ruler. So this was kind of cool, kind of an impulse buy, kind of under the $5 mark. I'm susceptible to impulse buying. But I thought it would be handy because I was looking for a real better fidelity way to get these things 90'd up. The ruler I was using works pretty good. I just wish the hash marks were a little longer. So I was kind of looking for something that would give me a line all the way across here. And so that's actually while I was at Harbor Freight, I just happened to stop in and I was looking for a ruler that had longer hash marks. And what I found was this guy here, which is kind of cool. It's got 3 different levels in it, having nothing to do with helis. 3 different levels in it. It's also got like a little scribe tool in here that you can use to scribe marks if you need to. So way cool. But what I found I like about it, particularly for the heli, I'm gonna give you a up close focus here. It's got an adjustable setting for your angle, so I can set it at 90 or I can, you know, put it at whatever for whatever project I'm working on. In this case, I'm setting these servos to 90, so I can set it to 90. And what that does is it gives me a 90-degree angle there. The cool thing is the way this is designed for that to slide into this plastic housing, right? Let me loosen it back up. So it's designed to go in there and basically stores that way. Which is cool, but what it does is it gives me a lot of surface area. So one of the challenges with checking for 90 on the servos is I want a lot of surface area to make sure I'm perfectly aligned with the side of the servo, the body of the servo. Otherwise my measurement could be inaccurate. And what I found is if I hold this at about maybe a 45-degree angle, I've got plenty of surface area, as you can see, against that servo. And then I've got room to kind of push down this actual metal ruler and use it as a guide. So I'm going to try and do this for camera. I went through and I aligned all of these servos using this method. I don't have any power to it right now, and basically found out that it worked pretty darn slick to be able to just get that aligned up. So what I'm doing here, actually let me power this on to get it to the true center. I'm still plugged into the Robird and to the ESC, so I'm going to apply some power. I'll even give it a little transmitter just to make sure. So basically what I'm looking at is, where's my stick? I gotta get my stick centered. Alright, so there's center stick. And basically what I'm looking at here, let's see if I can get down here for you, is getting as much surface area as I can and then slipping this across, and I'm looking for how those holes line up, and I want to see equal daylight on all the holes. Now I can look at shooting for the top of the hole, right? And the flatter I make it, the more easy it is to see that angle. But as you can see, it's a great alignment tool, and I can just kind of look and see. What I was trying to do is shoot for like a 50-50, where I can just see cross-section of the same amount of cross-section in all 4 holes. So that turned out to be a good guide, and you can see with different backgrounds it makes a difference. With black I can really see how they line up. So let me hold it over something black for you. So anyway, I just thought I would share that. I got it because like I said, I was kind of looking for something else, and I ran across this thing and thought, man, there's a whole lot of things around the house I can use this for, and it'll be really good for finding that 90. So that's what I did. I went through all these other servos and did the same thing. So that's that. I'm going to unplug. Don't need any more power. So that was just a little sidebar. All right, so the next thing I wanted to talk about is I did put the servo horns on, the servo arms. I mounted them to the servo because I set them, and I wanted to make sure I had everything aligned right. I did use Loctite or thread locker. In this case, I'm using Permatex thread locker because this is a metal gear servo, and I have these little metal screws that came with them. So I got those done. The next thing I had to do was get the ball links, the balls put on. So interestingly enough, that was a little bit more complicated, only because I had some work to do. I had to figure out which hole needed the ball. Now on the manual, it doesn't really show in any great detail where to mount the balls. I know the Align manual kind of shows you there's 2 holes on the Align manual on the servo arm, and it shows you to mount it to the inside hole. On the Tarot manual, it shows 3 holes on the servo arm, and it looks like it's on the middle hole, but it's kind of hard to tell. It doesn't give you like a dashed line to show you exactly. So I actually started out mounting on the next to the last hole, and was looking at it and thinking that it looked a little long. I was trying to figure out the orientation with the swash, you know, when I put it in the frame, and I wasn't real sure. So I went to the forums, and what I learned is that, and I don't see this in any manual, in the Align manual or the Tarot manual, but somebody posted that the proper distance from the center of the gear to the center of the ball is 12.5 millimeters. So I just did some quick measuring, set my caliper to 12.5, and lo and behold, that is the second hole from the inside. So that is why I have these mounted, 12.5, second hole from the inside. So I'm going to mount all 3. I got 2 of them done. I saved one of them for you because I wanted you to be able to learn from this experience if there's anything that I can bring up. So I'm going to mount that in this last servo. So there is one other thing, and that is it shows it in the manual, both the Tarot and the Align manuals. They show this little 2 millimeter nut that goes on the other side of the ball. Now, I've seen a little bit of discussion about whether you need a nut or whether you don't need a nut. And the kit did not come with these little nuts. It just didn't have them in the kit at all. And I've seen other kits as well that don't have them. So I don't know if it's a general oversight or if it's so optional that they just don't put it in there. So I've seen a lot of people that will take these and just thread them into the plastic, use a little bit of CA to hold them in place, and good to go. And that's probably perfectly fine. I decided to go ahead and get some of these nuts and use a thread locker to lock that in. So actually finding these little guys was harder than I expected. I thought I could just run to any hardware store, Home Depot, Ace, whatever, and find them. It looks like the smallest sizes they carry are generally 4mm. These are 2mm with a 56 thread. But interestingly enough, I finally called Radio Shack, and Radio Shack has these. This is a pack of 40 for like, I don't know, $2.50, $3, something like that. So I ran down, grabbed. I started calling because I was striking out left and right at hardware stores, auto parts stores. Everybody I expected to find these didn't have them. Radio Shack has them. They're called machine nuts, and they're in the same section with, you know, all the little electrical drawer components, all those little drawers full of components. So at any rate, I only need a few, but a few bucks for 40 of them. I've got a ton of them, so I've got room to lose some. So I did put the ball on, and then used thread locker for the nut. So let's finish this one up by putting that ball on there. I'm going to give you a little bit more of a close-up here. So remembering that we want, on this particular build, on this particular servo, we want to be on the second hole from the middle, from this center point here. So second hole from the inside. That may vary depending on what type of servo arm you have. It may be different for you. So the key here, measure to which one gets you to 12.5, and that's the one you want to use. So with that said, there is kind of a challenge here in actually getting the ball started in the plastic. You can crank on it. You know, obviously these are easier to put a ball on if you didn't already have it mounted to the servo. So I may or may not be doing this backwards by getting it set up on the servo. I really don't want to pull it off because I've got it all centered and set to 90. So rather than doing that, I'm going to just install it from here. So it's not that hard, but I will admit it would be easier if you could put it on a flat surface. Then you can really crank down on it. So I didn't do it that way, so you're going to see me do it maybe the hard way. So let me go get my ball, and I'll be right back. Okay, so I have my other ball that I'm going to put on, you know, that's kind of what they look like. They do have, it's the smaller, what was this, I don't remember what size this smaller hex is, but that's what it is, 1.5 maybe. So like I said, you can get on it if you have it on a flat surface, or you can put it on, you know, a tabletop or something to get it started. So getting this started was kind of a pain for me. So I'm cheating, and I'm using a little like 1/8 inch drill, and basically just barely. It doesn't widen the hole very much, as you can see. That is drilled, but just that little bit made a huge difference for me in getting that screw started. You can, you know, obviously you can drill it out wider than you need to because you're using, at least I'm using a nut to hold it on, but I still wanted it to thread through. But if I just get it started that far with the drill, it threads through pretty easy. And I'm just using my finger here. Like I said, if you used a countertop or something else, or could get it flat on the surface, it would be a lot easier. But it's going through pretty easy. And then I'm just kind of snugging it down as if I was just doing it straight through. As you can see, I've got plenty of room for threads. Also, I didn't lie to you. I told you I was going to mark these. This is the center servo, so this is the rear one. And I just put a big C on it. And each one, you know, left, L for left. So these are marked, so I know exactly when I go put them in the heli where they're going to go. And if I ever decide I don't want them marked anymore, I just change out the black tape. But hey, not a problem. All right, so let me get one of these little machine nuts here. And then basically get my thread locker. I'm just going to get a little bit on there, make a huge mess. That's what I'm good at. And then I just start it and spin it on. And once I get it there, I've been using this to kind of help stabilize it, even though I'm really not going to be turning that. I'm going to be using just tightening against, and I'm getting a lot of mileage out of these ball link pliers. So just when I'm lightly turning it, I'll use those ends. But when I want to crank on it, I'll come down here and just give it a little pressure, get it snug. And there we go. So now we have the ball link on there, or the ball, and we are set. So I now have 3 of these guys, and the next thing we're going to work on doing is finishing up the ball links. All right. So for these ball links, the manual says that it's supposed to be set to a 33 millimeter. So zero this out. And get it pretty close, 33. That works. Get that locked in, and then I can turn it off because it's where I need it. And as you can see, I've done 2 of these already. And just, you know, got it as close as I could to the points in the center. There we go. So I've got one more to do, and these are threaded on either end, which is a little bit of bar in the middle. And again, I'm getting a lot of mileage out of these ball link pliers, trying to earn their keep here. So holding on to it centered, and then these just thread on normal, righty-tighty, lefty-loosey. There's no back threading or anything like the other ones that were adjustable. Basically just turn it on the way you would expect to do it, and then get to the other side. Screw that on. And when I start getting close, I start wanting to look at the A's and kind of keep them on the same side. Dang, I must be getting good at this. Looks pretty darn good there. So that'll be it. So now I have these 3 links done, and that will come in handy once we get the main shaft in. So the next thing I'm going to work on is going to be dragging this frame out, and we will start working on getting that main shaft, main gear, motor, and then after that I'll get those servos installed, all 3 of them. So coming up is the main gear.